Let's move on to the fourth example. When an airplane leaves the runway, its angle of ascent, so that's heading up, is 19.5 degrees. After 2 minutes, the plane has traveled 6,000 meters. Determine the altitude or the height of the plane. So we got to draw something. So it's leaving the runway. So we've got a runway that's going to be horizontal, and the plane is lifting off. Okay. And so here's the plane. It's lifting off. And it says the angle of ascent. So that's this angle down here is 19.5 degrees. Now, it says that after 2 minutes, the plane has traveled. So the distance after 2 minutes is 6,000 meters. So we have 6,000 meters. This is how far the plane has flown over the last couple minutes. And what we want to determine is what is the altitude of this plane. So we have a perspective, 19.5, so we can look across. That's going to be our opposite. And our 90 degrees here, opposite of that is always our hypotenuse. And then that leaves this as the adjacent. And again, we're trying to find out what this is. So I have hype, and I need the op, H and O, so that's going to be a sine formula. So, I don't know why I'm doing that. So, I have to use the sine formula. Sine of theta equals opposite over hypotenuse. Now, I do know the angle. They gave me the angle. They said, hey, it's 19.5 degrees. That's how much we're ascending. We're heading up. The opposite is unknown. So that's what we're trying to find, but we have the hypotenuse, which is 6,000. So we do not know that. I'll just call that x. And then 6,000. So now I need to figure out what is sine of 19.5. So we see it here, sine of here's 19.5, sine is this one, so 0.3333, which is a third. So this is 0.333, but really this would kind of go on forever. I don't think sine 19.5 is going on forever, but we can say approximately that this is the same thing as a third. Now I'm trying to get this x alone, so I'm going to get rid of this divide by 6,000 by timesing, do the opposite. And so that'll cancel on this side. So now I'm doing a third of 6,000. Or you could think about it as 6,000 times 1, that's 6,000. And then 3 times, well, there's nothing there, but there's a 1, so 3 times 1, so 6,000 over 3, which is how you end up getting 2,000. So I'll write it like this, 2,000 on the left equals x. So now we can say in a sentence form, the height or the altitude of the plane is 2,000 meters. And that is that. So I'll just zoom out here. You can take a look. And we can move on here to the next one. So what does it say? A passenger plane is flying at an altitude of 14 kilometers. That's a pretty high altitude. Okay, so it's up in the air already. And a city is spotted out the window. The angle of depression to the city is 35 degrees. So I'm just going to stick with that. There's a passenger plane and it's flying. So here's this plane. Yes, it's flying in the air. I don't know what's going on here. Here we go. So this is plane, it's flying in the air. Okay. And it spots in the distance a city. Okay. So we got a city here. Now, it says the angle of depression. Depression's heading down. So it spots the city at an angle of 35 degrees. So it's looking down. So the angle is down is 35 degrees. And what we want to know is how far horizontally, so that's left and right, how far horizontally would the plane have to travel to be directly over the city? So if the plane were to keep flying, how far would it have to fly before it's right above the city? So what we're trying to find is this distance. So this is unknown, and we have this distance. It's like, okay, well, what is this height? Well, they already told us the height of the plane is 14 kilometers. So I can label, looking from my perspective, this is the opposite. Here's 90 degrees, so that would be the hypotenuse, and this leaves the adjacent. So it looks like I have the opposite, and I need the adjacent, which is TOA. I'm going to write that down. TOA. T-O divided by A. So that's tan of some angle, theta, equals opposite over adjacent. And it does give us the angle. The angle it said was, I don't know, 35 degrees. Equals opposite. Well, opposite's 14. Over adjacent, we don't know what that is. We'll just call that x. So I guess I got to figure out what tan of 35 is. So 35, whoops, where's that here? 35, 700, 0.700. So this is 0.700 equals 14 over x. Now we don't like x on the denominator, so I'm going to multiply both sides by x. That's going to remove it from the right and put it on the left. So I have a 0.700, and I have an x on the left, and on the right is just a 14. So now to get the x alone, I can divide by 700 and divide by 0.700. So those are gone. So I get this weird thing, which is 14 over 0.700. Now, whenever you're dividing by decimals, you can move the decimal over as long as you do the same thing on the numerator and the denominator, or the top and the bottom. So I'm actually going to move this over by 1, and we're going to make that a 7. But then I got to do the same to the top. I got to move that over by 1 and make that 140. So I basically had to add an extra 0 there, and I moved the decimal place over here. Well, 14 over 7, that's just a 2 with the additional 0. Or 140 divided by 7 is 20. So that is our answer, 20. So what were we asking again? What is the distance that it would have to travel before the plane is right over the city? And the answer is 20. And it looks like our units are kilometers. So we can just say the plane would have to travel to travel 20 kilometers to be directly over the city. And there we have it.